So I welded these two guys, made a little more space for the cross member, and now I can get the engine further down and a little backwards. So I had to make a little modification on the pan. But as I welded so much, and as the shape is like this, when I welded it basically warped. So now I need to resurface the pans, but I'm gonna do that on a mill, so it's not a problem. I also got my oil pans back yesterday, so we machined them straightened them up. So I'm still going to make a one sensor location here, just to tap, bore and tap one additional temperature measurement point. So I usually measure oil temperature on the inlet of the engine. So in my case, it's actually on the little filter adapter that I've done. So this is where I measure the oil temp. So the dry sump pushes the oil through from the A-in thread and then through the filter and to the block. So I don't use an remote oil filter just to avoid one line. So yeah, I also want to see now what the oil temperature is here when it basically is. This is the point where it is coming down from the engine, draining down to the sump and being sucked by the dry sump back to the oil tank. I have also a possibility to put a sensor on the oil tank, but I think it already, because I have a oil cooler and so on, so the temperature, the hottest point basically is here in the pan. So that's what I want to measure. Okay, let's close the coffin. Relatives have seen. That's how we say it in Finland. When we put the oil pan and tighten it up. Or when we install the oil pan and tighten it up so that there's no way going back. So, I got my clutch back. I sent it over to ZF to be inspected. This has been in the car. The first race I drove with this clutch was Mount Washington 2017. So it's been in the car ever since. And I wanted to know if it's all good with it. And the guys at ZF measured the clamping load and verified that it's all good. So the disc is in very good condition. There's no need to do anything for the clutch at the moment. So the nice thing about this clutch is that it has a separate adjuster ring. So actually you can change here the ratio for the spring, which changes then, or the contact point for the spring, which changes the ratio and which changes the clamping load. So I've got two settings for this. It should be mentioned in somewhere. Oh yeah, here. So the low clamping load is 240 newtons and the standard is 300. So I've been using the 300 137. Yeah, this is the 300 Newton meter option I have here now. What I also have is the, so here this is the second spring, and here I've got another friction material. So this is slightly different than the one I'm running. This is now a little experimental to try these out. SF27. Yeah. So this SMF 027 has less judder, more wear to bed in with care. So this I haven't tested in the car yet, And then the one we have in here is a proven type, SFM 013. So it's pretty cool. Got some really good friends that helped me with this stuff. Very happy about it. Not to mention the names, but thank you very much. Yeah, so I'm just gonna clean all the parts. Has a little bit of dust here and there, so just gonna clean them and then assemble the clutch. Next step is gonna be I'm gonna pull the engine. I assembled the engine yesterday. It's now ready. So I'm gonna take the engine off the stand, put the flywheel on, put the clutch in, and then gonna get ready to put it back in the car. So I'm gonna fabricate some new engine mounts and things. So I'm not gonna put the auxiliaries on it because I can easier access the engine mounts. So then once I've fabricated all, then I'm gonna put the alternator, oil pump, etc. and finish the engine. But it's still gonna come out of the car. So all these parts have a mark. Also there's marks in the housing that how it should be assembled. And now the spring so the spring plate is or this elastic pressure ring is in the groove properly. So the carbon I don't really want to clean up. I'm just gonna use a little bit the air to get the dust out of it, but I'm not going to use any brake cleaner or any solvents on the carbon. So I was thinking about testing this, since I will have a chance to, of course I'm gonna go to dyno possibly several times, do some testing before next season. I could drop in this experimental type disc and see how it works. I think it would be the right moment to do it now. That's it, then it's ready to go. I used earlier Alcon clutch, so I got a 2.5mm step on the flywheel, so this is now made to match the flywheel that I have. So in theory, as a backup clutch I'm still using if I would ever have a problem. I can switch quickly to the Alcon back, so I have a spare clutch. So one of the key differences with the clutches when I switched over from the typical Alcon clutch to this one is that the pedal feel and the how the clutch releases and the biting has way more feel with this clutch. And now, especially with this experimental disc, it should be even better. So we'll see. So now I'm a ZF clutch salesman. One thing I forgot to mention, this was actually, I think it was 1.3 kilos lighter, this ZF clutch, versus the typical Alcon, with the same diameter and everything. So I think the Alcon is a little bit overkill what comes to the clamping load for such a small, high RPM, naturally aspirated engine, which doesn't really make torque. And the clutch housing is very heavy on the Alcon. So I purchased new bolts for the starter motor and to hook up the gearbox to the engine block. So these are original Toyota. They have a smaller tool size, so as this is very close to the firewall here, it's easier to use the smaller 17mm tool than the 19mm. So there's shorter ones on the top and then the longer ones come here. Just gonna be a little easier. So I'll just put a few bolts in here. Going to tighten this up with the thread locker. So I've run out of Loctite 242, so I'm gonna use Permatex red on the flywheel bolts. And this goes in the thread, and then you want to put some moly lube on the washer. or there's not going to be a washer, but on the contact surface. Okay, I have to clean all the excessive moly lube from here, otherwise it's gonna spread all over the place when this is gonna spin 11,000 RPM. Okay, so I couldn't find my tool for centering the clutch disc, so sometimes you just have to find your inner MacGyver and figure out something. So I used a 12mm bore, a 14mm half-an-inch socket, and which fits perfectly into the clutch disc and has a 12mm bore inside. So this is pretty tight, and quite sure it's well centered. But we'll see it soon when I try to drop the engine in. So the thing which really annoys me is I spent, I think, an hour trying to find the tool. I couldn't find it. However, I was able to find some stuff that I've been looking for, so it was not completely waste of time, but still really annoys me. The engine would be already in if I would have found the tool right away. So I've used these T3 brackets before Pikes Peak. I was really in a rush to get the engine in the car. I ordered these, modified them to get the engine sitting further back than these originally are. They are not very pretty. They are also very heavy. Plus the engine still won't sit in the right place, so now I'm going to finally fabricate some proper engine mounts. Okay, so that's how much I have space between the clutch spring and the release bearing when it's fully pushed back. So there's definitely enough. So as you can see now, the modification I made for the oil pan allows me to drop the engine maybe 2-3 centimeters and actually move it also further back. So I think I'm gonna get it maybe 2 centimeters back and 20-30 millimeters down, which is gonna be great for the weight distribution. So this is still the original cross member in the original location. So I need to move the cam sensor from the back of the cylinder head, because that's now my limiting factor here, moving the engine rearward. So I'm gonna make another trigger wheel configuration and sensor location, most probably here on the top of the valve cover, to read the same trigger that I've built into the cam, but just move the sensor. And since it goes, the engine moves lower, there's gonna be much more space on the transmission tunnel, which is not bad at all, because it's pretty tight to get the fingers in there if you need to move the remove the gearbox.